So I am recording this. Feel free to stop me if you need. If you have any questions, it's all good. I could always pause and then continue recording. We're going to begin with this class opener. Everybody should know how to how to graph linear equations. And we learned different forms, but what you need to remember is y equals mx plus b. We need to remember that the number in front of x, when y is by itself, the number in front of x is a slope, which is really a rise over run. It's a fraction, rise over run. The rise could be positive if it's going up, or it could be negative if it's going down. The run, you're always going to look at it in the positive direction from left to right. And the b value is simply your y-intercept, where it crosses your y-axis, okay? So knowing y equals mx plus b, we should be able to clearly identify the b value, which is -3. That tells us where it crosses the y-axis. So everybody go to the y-axis at -3 and put a dot right there. Then from that dot, we know our line that our line passes through that dot. How does it, bless you, how does it cross? It depends on your slope. That'll tell you your steepness. So your slope is the fraction in front of your x, which is rise over run. So it's going to rise 1 and run 2. The reason why it's going up 1 is because the fraction is positive. If the fraction were negative, it'd be going down. So because it's positive, you're going up 1 over 2, and you put a dot right there. And you could continue to go up 1 over 2 and put a dot right there. And you could even go backwards. Over 2, down 1, over 2, down 1, over 2, down 1 to extend it in the other direction. And then you connect your dots, and you're done. You guys remember that? It's pretty easy, right? Y equals mx plus b. All right, number 2. Whoops, what happened there? Right here, it's ready to graph. It's already in y equals mx plus b. It crosses at 3. Put a dot at 3. From that point, my slope, the fraction in front of x, is 2 over 1. So it's going to go up 2, not down 2, because it's positive 2, not negative 2. So it's going to go up 2 over 1. Again, make that look like a fraction. That way you could see how much you run. So you're going to go up 2. And if I do go up 2, I'm off the graph, but I'm only 1 unit off the graph. And I run 1, and I'm right here at this dot. Because it's so close to the edge, I'm going to put the dot right there. However, it's not good enough to just draw a line like that. That's too small. So what we're going to do is use the pattern of up 2 over 1 backwards, over 1 down 2, over 1 down 2 to get to this next point down here, and continue with that pattern of over 1 down 2, over 1 down 2, so you could extend it all the way. Then you draw your line, put some arrows, and you're done. Now, just to review, do you guys remember what this line with the arrows actually represents? It represents the infinite amount of answers that exist to an equation. What is an answer to an equation? If you plug in a number here and a number there, if it gives you a true statement, that's an answer. If you plug in a number for x and a number for y, and you plug it in and it doesn't give you a true statement, it's not an answer. So for example, if I plug in any of these points, it will work. Like let's say I plugged in this coordinate right here, which is -2, -1, okay? Plug in a -2 for your x value and a -1 for your y value. So writing it y, instead of y, I plug in a -1. It's -1 equals 2x, but instead of x, I'm plugging in a -2. And then plus 3 at the very end, plus 3. So when I do the math, 2 times -2 is -4. -4 plus 3 is -1. And it is equal to -1. As you can see, we verified, we double-checked that this x and y value does work. We already knew it was going to work because the line represents the infinite amount of answers that exist to an equation. So any dot that's on this line will work for the equation. That's a concept that we should know because it'll make more sense on today's section. Moving on to number 3. You see, number 3 is in standard form and number 4 is in point slope form. But we could change them all to slope intercept. That's what I recommend. Just get y by itself. So we're going to get rid of the 3x by subtracting 3x. We're going to rewrite the whole thing. It's going to say -2y equals, write your x term first, -3x with a +6 second. We're almost done. We need to get y by itself. That really says -2 times y. You don't want that multiplication of -2, so what do? Divide. Divide by, whoops. Man, sorry about that, technical difficulties. Divide by -2, divide by -2, divide by -2. That cancels out. I will have y by itself equals, now a 3 divided by 2 you cannot do, but a negative divided by a negative is a positive. So at the very least, you could rewrite it as a positive 3 over 2 with an x on the side. And then over here, 6 divided by negative 2, that is a negative 3. So now it's in slope-intercept form. We know that it crosses the y-axis at negative 3. And from that point, I rise 3 and I run 2. So it crosses at negative 3. And from that point, I rise 3, 1, 2, 3, run 2, and put a dot right there. Why did I rise 3 and run 2? Because it's rise over run. The slope tells us to rise 3 and run 2 from that b value of negative 3. So up 3 over 2, you could continue to go up 1, 2, 3 over 2 and put a dot right here. And then, of course, you just connect your dots, put some arrows on it, and that's your line that represents the infinite amount of answers that exist to this equation. So if I plugged in any x, y value on this line, it'll work. When I plug it in right here for x and right there for y, it will give me a true statement, 6. Anyway, number 4, it's in point-slope form. And yes, we could graph it by identifying the point and using the slope, but I recommend changing it to y equals mx plus b. Y equals mx plus b does not have parentheses. So let's get rid of those parentheses by distributing the 3. 3 times x is 3x. 3 times 1 is 3. Bring down the equal sign, bring down the y plus 2. Okay, so I almost have y by itself. All I have to do is get rid of this plus 2 by doing the opposite, minus 2. On what you do to one side, do to the other, minus 2. Rewrite the whole thing. Y equals, the slope is technically 3 in front of x, or you could also say 3 over 1, because it's not a fraction. Make it look like a fraction. And then plus the b value, which is plus 1. This is now in slope-intercept form. We now know that it crosses at 1, and from that value, I rise and run according to my slope, which means I go up 3, 1, 2, 3 over 1 and put a dot there. And if I wanted to extend the line in the other direction, I would go backwards, over 1, down 3, over 1, down 1, 2, 3, and put a dot right here. And then, of course, you connect your dots, put some arrows on it, and there's your graph. Does everybody remember how to graph with y equals mx plus b? All right. If you know how to graph with y equals mx plus b, you're going to love this section. It's a piece of cake. But before moving on to today's actual section, we're still on the class opener. And let's review some skills from last week that will help us on this new section this week. We're going to put a 2 right in the middle. And there's a lot of numeric values here. So how about this? Let's skip every other one. So going to the right, I want to say 3 and 4. Notice that I skipped it. That way we don't have to write that many numbers. And to the left, we're getting less values like 1, 0, and negative 1 over here on this side. But anyway, that's already good enough to graph this x is greater than 2. Is it going to be a solid dot at 2 or an open dot at 2? It's going to be an open dot, right? So it's going to be an open dot at 2. And am I going to the left or to the right? To the right. Okay, why? Because that's a greater than symbol. Greater than's to the right, less than's to the left. Not only that, I mean, numerically it makes sense. Over here, there's a 3 and 4. These are greater values than 2. So to the right is to the, greater than's to the right, less than's to the left. And if you're totally confused, look at your inequality. Where's the point at? The point is on the left, on the right side of this inequality. It's pointing to the right, so it has to point to the right. Make sense? The other one, it's going to have a solid dot at 3. So let's all just put a 3 down here in the middle. It's going to be a solid dot. Fill it in. And this one has a point to the left. So it's going to be pointing to the left. Of course, I didn't fill in the values like a 2, a 1, a 4, a 5. And there's your graph. That was a skill that we needed to have learned last week. It's a skill that you need to know this week. Now, that makes sense when I look at the inequality and I graph it on a number line visually. But what if I read it to you in a sentence? Let's see if it makes sense to you. Okay. On a horizontal x number line, that means horizontal, left and right. If you have x is less than a certain value, then the area you're talking about is to the left of that value or to the right of that value. What do you think? Come on, give me the answer, anybody. To the left, right? Think about it. You have your horizontal number line. No matter what number I tell you, if I say x is less than that certain number, well, that'll be an open dot going to the left. So this is the correct answer, to the left of that value. Why is that? Because less than is to the left. Greater than is to the right. And we understand that using the x-axis, the x number line. Now, what if we were talking about a vertical a vertical number line, okay? Think about this, a vertical number line, which is technically the y-axis. You have 0, 1, 2, 3, 4. Like, what if I told you that y is less than a certain value? Like, what if I said y is less than 3? What does that mean? Is it an open dot or a closed dot at 3? Open dot at 3, because it does not have a solid line underneath it. If it did have a solid line, it would be a solid dot, but it doesn't, so it's an open dot. And which way is less than, not on the x, but on the y? Is less than going up or is less than going down? It's going down, so that would be the correct answer to this question. On a vertical y number line, if y is less than a certain value, then the area you're talking about is below that value. Make sense? Okay, now these are all essential skills on today's actual lesson. Let's go to today's actual lesson. It's up on the right corner, notes 5.6, graphing linear inequalities. So graphing a linear inequality is the same as graphing a linear equation. It just has 2 extra steps. Couple means 2, right? So how did we graph before? Well, you first got to make sure that it's in slope-intercept form. Slope-intercept form being y equals mx plus b. So first make sure that it's in slope-intercept form, y equals mx plus b. And once it's in slope-intercept form, then you know where it crosses the y-axis, you know how much you rise and you run. But before you actually draw your line, you have to determine if it's a solid line or a dotted line, okay? So let's pause right here on these first 2 steps, and let's do that down here. Number 1, it's in slope-intercept form, y equals mx plus b, but obviously we don't have an equal sign, we have a less than sign. But anyway, we do know that the b value is what? -1, and the slope is what? What's the slope? -1/4. So everybody put a dot at the b value of -1. That's the y-intercept value of -1. That's your b value. And then from this dot, you're going to rise and run according to this fraction. So am I actually going to go up 1 or down 1 based on this sign? Going down 1. So I'm going to go down 1 over 4. 1, 2, 3, 4. So everybody go ahead and put a dot right here. And you could even use that pattern backwards. Instead of going down 1 over 4, go over 4, up 1, over 4, up 1, and put a dot over here. And normally on equations, on the class opener questions, all you do is draw a line and you're done. Put some arrows on it. However, right here, it's an inequality. So we need to do step 2 to determine if this line is a solid line or a dotted line. What do you think? Is it going to be a solid line or a dotted line based on this inequality symbol? Dotted. Why dotted? Because in order for it to be a solid line, it has to have an or equal to. It has to have a solid line underneath your inequality. So everybody go to these 3 dots and do a dotted line connecting these 3 dots and put an arrow on it. That's one additional step compared to what we did on the class opener. Now the other additional step is identifying where your answers are at. Your answers are either going to be on one side of the line up here or maybe on the other side of the line down here. It can't be on both, okay? An inequality is talking about an area of answers. So the answers are either going to be on top or on the bottom, okay? So how could you check if a point is an answer? Anybody? How could you check if a point is an answer? Like, let's say I told you to check the coordinate 4, 4, 2. 4, 2. It's that yellow dot right here, right there. And how could you check if that's an answer? Well, you would have to plug in 4 for x and 2 for y into your equation. And if it works, then it is an answer. If it doesn't work, it's not an answer, which means that your answers are going to be on the other side. Does that make sense? Okay, so if I were to plug in the x value of 4 and the y value of 2, instead of y is less than, you would have 2 is less than -1/4 times x times 4, and then minus 1. So if I do plug in an x value of 4 right there and a y value of 2 right there, will it be a true statement or a false statement? If it's a true statement, it is an answer. That means that all of my answers are up here. If it's a false statement, it's not an answer, which means all my answers are down here. So when I go negative 1/4 times 4, what is that? What's negative 1/4 times 4? Negative 1, right? The 4's cancel. You have a negative 1, and then take away 1. What's negative 1 take away 1? Negative 2. Thank you so much. Bring down that inequality. Bring down the 2. Is that a true statement? Is positive 2 less than negative 2? That's false. Positive 2 is greater, right? So this does not work, which means that this point is not an answer. Does that make sense? So where are our answers at? If they're on the bottom. So you would have to shade in everything down here because your answers are down here. If I pick any point down here and I plug it into X and Y, it will be a true statement. Any point up here, it will not be a true statement. I picked 4 and 2 because a 4 would be nice to have right here for X, but the easiest point to use is 0, 0. If you tested the point 0, 0, plug in 0 for X, 0 for Y, it'll be a lot easier. Plug in a 0 here, it'll become 0. And then plug in a 0 over here, what is it going to say? It's going to say 0 is less than 0 minus 1. 0 is less than negative 1. That's false. So even if you were to test the point 0, 0, it still doesn't work, which means that the answers are not on this side of the line above it, but they're actually on the other side of the line below it. Some students are like, man, I don't want to be plugging in X and Y values to see if it works or it doesn't work. Well, I do have a shortcut that'll help you out, all right? You see, when you have Y all by itself, and you think about Y on the XY plane, you're talking about up and down, right? Y is up and down, X is left and right. So when you have Y all by itself, what does it say? It says Y is what? What does it say? Is that a greater than or a less than symbol? That's a less than symbol. Y is less than. So if I go to any part of this line and I put my pencil on it at this red dot, where would the less than be? Would it be above on the Y or below on the Y? It'd be below on the Y. So that's how I know I have to shade in the bottom. So you don't even have to actually test the point, or not even the easiest point 0, 0. You could just understand where you're going to shade based on your inequality. If it's less than, Y is less than on the Y is below. If it says Y is greater than on the Y is above. Make sense? Let's go through this next one. I know that was the very first example of you've seen. Let's check out this next one. Where does it cross the y-axis? My b value is what? Negative 2. So go to negative 2, put a dot there. And then from there, our slope is what? 4 over 1. So you're going to go up 4 over 1. So you're going to go up 1, 2, 3, 4 over 1 and put a dot right here. And you could continue to go up 4 over 1. You'll beat a dot out here. But the bottom line is this is our line. And we're just going to draw it all the way through. But before drawing it, the first extra step is deciding, do I draw a solid line right through these two dots or a dotted line? Solid line. Why solid? Because it has an or equal to. The solid line underneath the inequality, we're going to draw a solid line right here. So go ahead and draw a solid line. That's one extra step, deciding if it's solid or dotted. And the last step is to determine where your answers are at. Are they above the blue line, up to the left, or are they down here, bottom to the right? Now, the quick and easy way of doing it is, well, Y is greater than. So what does that mean? Above or below? Y is greater than. That means above. So if you put your pencil at this dot, where is greater than on the Y? It'd be above. So if you actually just put your pencil on the dot and draw a line above, it already shows you what side you're going to shade. You're going to shade in everything that's over here. Make sense? And that means that any point over here will work when you plug it in. None of these points over here will work when you plug it in. All of these are solutions. After all, this is why we graph, to be able to represent the infinite amount of answers that exist to an equation, or in this case, to an inequality. Okay? So like, for example, let me verify this to you. If I pick any point, let me just pick this point right here. This red dot right here is the coordinate -1, 1, 2, 3. So -1 for X and 3 for Y. If I were to plug in a 3 for Y, it's going to be saying 3 is greater than or equal to 4 times x, and we see that x is -1. So 4 times -1, and then a -2 at the very end. So when I do the math here, 4 times -1, that's -4. -4 minus 2 is -6. So this inequality really says 3 is greater than or equal to -6. And that is for sure a true statement because +3 is greater than any negative number. So this point right here, it really does work. That means that it's a solution. That means that all these points are on this side are solutions. If I were to test any point over here, it would not work, okay? So what are we learning today? We're learning 2 extra steps. We already know, we could even go to the class opener. We already know that if an equation is not in slope-intercept form, we get y by itself. It crosses at 1, you rise 3, run 1, draw your line. But on an inequality, the only 2 extra steps is before you draw your line, is it a solid line or is it a dotted line? If it has a solid line underneath it, it's solid. If it doesn't, then it's dotted. And then you got to shade either above or below, depending on your inequality. So we have a couple more right here. Number 2, y is not by itself. Let's get y by itself. What do I do to get y by itself? Even before that, we're going to subtract 3x and subtract 3x to get y by itself. We're going to have -2y is greater than, we have a -3x plus 6. That really is saying -2 times y. To get rid of that multiplication of -2, you're going to divide by -2, divide by -2, divide by -2. And I hope your brain's like ringing a little bell right there, a reminder, when you divide by a negative on an inequality, what must you do? Change the symbol, right? So that greater than symbol is going to become a less than symbol. And you can't divide 3 by 2, but a negative divided by a negative is a positive, so it looks nicer when you make it a positive 3 over 2. It still has the x right next to it. The 3 over 2 is a slope. And over here, the b value, 6 divided by -2 is -3. And this is your slope-intercept form inequality. So what does this mean? That it crosses the y-axis at -3 down here. And from this point, I am rising 3 because it's positive, and I'm running 2. Rise 1, 2, 3, run 2, put a dot right here. I hope everybody's keeping up with me on your notes. And then we're going to rise 3 again, 1, 2, 3, run 2, put a dot right here. And now I need to draw my line. If it were an equation, I would draw my line and I'd be done. But it's not an equation, it's an inequality. So is this going to be a solid line or a dotted line? Dotted. Okay, so we're going to put some dots. And the final thing we have to do is shade. So are we going to shade above this line or below this line? Below. Why? Because it's a less than symbol. So we're going to shade below the line. Make sense? Last one. You want to get y by itself. So we're going to get rid of the multiplication of -3 by dividing by -3, dividing by -3, dividing by -3. Keep in mind that there's an invisible 1 in front of the x. And yes, we are dividing by a negative, so that's going to be y. And because you're dividing by a negative, you're going to have to flip that inequality symbol. It's going to become a greater than or equal to. And the slope is you don't want 1 over -3. So let's take that negative sign and move it up to the top, okay? So we're going to make that a -1 over +3 with an x on the side. And for the b value, a -9 divided by a -3 is a +3. So +3 right here. And now it's ready to graph. It crosses at 3. And from that dot, you're going to go down 1 over 3. So down 1 over 1, 2, 3. Put a dot right there. And you could use that pattern backwards, over 3, up 1, over 1, 2, 3, up 1, to put a dot right there to extend it in this direction. After you have your dots, we need to decide if this is a solid line or a dotted line. What do you think? Solid. Why solid? Because it has or equal to, it has that solid line underneath it. So here it is, solid, going right through those dots with arrows on it. And then we either shade above or below, depending on the inequality. That's a greater than. Which way is greater than on the y? Above or below? Above. So we're going to shade in above. So it's a little tiny triangle of a shade. Now, there's really an infinite amount of answers. Any coordinate up here, any coordinate way up here above this solid blue line will be a solution. Any point down here will not be a solution. So I hope that makes sense. You graph it exactly the same as you would a line in y equals mx plus b, an equation in y equals mx plus b. The only difference is before drawing your line, you have to decide if it's solid when it has a solid line underneath it, or dotted if it doesn't have a solid line underneath it. And then you also have to decide whether you shade above or below. If it's a less than, you shade below. If it's a greater than, you shade above. It's that simple. Now, there's only one other situation that may be confusing. Check it out. You don't have this on your paper, but just pay attention right here. It says, if you have x equals a number, I hope we remember this from back in unit, I don't know, whatever chapter it is when we graphed lines. If you have x equals a number, then it's going to be a vertical line crossing the x-axis at that value. So for example, I have x equals -3. You go to your x-axis, you go to -3, and you put a dot right there, and then you draw a vertical line going right through that value. You guys remember that? Okay. And how about y equals 2? You go to the y-axis. Hold on a second here. Y equals 2. You go to the y-axis. You go to 2. You put a dot right there. And you draw a horizontal line going right through it. Okay, so whenever you have x equals a number, you go to the x-axis. You go to that value. You draw a vertical line right through it. Whenever you have y equals a number, you go to the y-axis. You go to that value. And you draw a horizontal line right through it. Now, we need to remember that from before to be able to graph this inequality right here. X is greater than or equal to 2. Now, this is still not on your worksheet, but it's still important to understand. You're going to go to the x-axis. You're going to go to 2. You're going to put a dot right there. You're going to draw your vertical line right through it. But the question is that going to be a solid line or a dotted line? It's going to be a solid line or a dotted line? Solid, because of this solid line underneath. So this is going to be a solid line going right through there. And then you got to shade either one side of the line or the other. Now, before I would say if y is less than, you shade below. If y is greater than, you shade above. But the problem here is you don't have y. You have x. So you got to think back in terms of x. If x is greater than, is that to the left or is it to the right? To the right. So you're going to shade the right side of this blue line. So you're going to shade everything over here. Okay. How about this one, number 5? This one you do have on your worksheet. It's on the back side of your notes. On number 5, on the worksheet, which is behind the page of notes that I just gave you, it says y is less than -1. You're going to go to the y-axis. You're going to go to -1. So go to the y-axis, go to -1. You're going to put a dot right there, and you're going to draw a horizontal line right through it. But before drawing it, is it going to be a solid dot or a solid line or a dotted line? Dotted line. So do a horizontal dotted line right through it. Put some arrows on it, and then you got to shade either above or below. What do you say? Less than is below on the y. So shade below. And there's your answer to that one. So we have the rest of the class today to do this worksheet. This worksheet is great practice for graphing. Again, you just want to get y by itself first. So if you look at number 1, y is not by itself. You're going to have to get rid of the 2x by adding 2x, adding 2x. When you rewrite it, it's going to be y is less than 2x plus 2. Put the x term first and the constant second. Now, just by seeing this, I know that my line has to be solid or dotted. Dotted, and am I going to be shading above on the y or below on the y? Above the line or below the line? Below the line. So which one of these 4 options is dotted, shaded below? Option B, that's the only one. That's the only one that's dotted and shaded below the dotted line, right? So we didn't even have to think about the y-intercept and the slope. I mean, you could have said, oh, it crosses at 2, crosses at 2. What do I do from there? I go up 2 over 1, backwards over 1, down 2 over 1, down 2 over 1, down 2. There's your line. It's dotted, it's shaded below. All right, so you guys have the skills to do this worksheet. This will be on the test this Friday, and it also comes out on the final exam next week. So it's very important that we practice this. You could work on this for the rest of the class. You could double check your answers on Google Classroom. Everything's there. And not only that, there's 2 videos explaining every single question on this homework.